Right, Eg6. A light horizontal beam of length 2 meters rests with ends A and B on smooth supports. The beam carries masses of 5 kilograms and 2 kilograms at distances of 60 centimeters and 150 centimeters respectively from A. Find the reaction at each support. Okay, so this time it's telling us that the beam is light, and what that means is that it's got negligible mass. So whereas in Eg5 it had a mass of 4 kilos which we could place centrally on the beam, this time it's negligible. We don't have to, well, there's no mass to include. Okay, so the light beam means negligible mass. Okay, so we'll draw ourselves a nice little diagram. This was of length 2 meters, A and B on smooth supports. So I'll put one support there at A, one support there at B. We're going to have a reaction at A, and we're going to have a reaction at B. It also mentions in the diagram, or in the question, sorry, that the supports are smooth. Now, because the supports are smooth, we haven't got to worry about any frictional forces that may be taking place at point A and point B. So we haven't got to worry about any coefficient of friction between the material of the beam and the supports, and we don't have to deal with that at this level, so they'll always be smooth. So the beam carries masses of 5 kilograms and 2 kilograms at distances of 60 centimeters and 150 centimeters. So I've got a mass there of 5. Now, one thing you need to be careful of in a question like this is that you are using the right units, and 60 centimeters, we need to put that in terms of meters, so that distance there is 0.6. And then we've got another another mass of 2 kilograms at 150, so that's halfway, which is 1 meter. So we've got what did I say, 2g acting there, and that's going to be a distance from A. I'm going to take my moments about A, so if I write that as 1.5 meters from there rather than working out that distance there. Okay, so we've got everything we need to have on the diagram. Like I said, it's a light beam, so there's no center of mass or no mass of the beam that we have to worry about. Okay, we want to find the value of RA and the value of RB. System is in equilibrium. Therefore, the sum of the y forces equals 0, and the sum of the moments about A, which is where I'm going to go from, equals 0 as well. So if we set up the force equilibrium first of all, I'm going to have RA minus 5g minus 2g plus RB equals 0. So RA plus RB equals 7g. So that's my first equation. Now, when I'm forming my moments equation, you're free to choose wherever you want, but it makes sense to pick a point which will make one of the unknowns have a moment of 0. So you're either going to take moments from A to make that go to 0, or moments from B to make that go to 0. You don't have to. You could form an equation by taking it from the centre, and then you'll have a pair of simultaneous equations with RA and RB in, but you're just making more work for yourself than choosing to eliminate. So we're taking moments about A. So RA times 0, because there's no distance, no perpendicular distance from there. Then we got the 5G. Now the 5G is trying to turn that in a clockwise direction, so it would be positive. Then we've got the 2G, which is also going to try and turn that in a positive direction. Then we've got RB, which is 2 meters away, but that is negative. That wants to turn it in an anti-clockwise direction. So we are going to be able to find RB from this. So 2RB, take it over to make it positive, and then here I'm going to have 3G plus 3G. So 2RB is 6G, so RB is 3G newtons. And then by putting that into 1, you've got RA plus 3G equals 7G, so RA would be 4G newtons. So you've got RB is 3G, RA is 4G. If you just leave them in terms of G, you haven't got to worry about rounding them, because you aren't calculating the actual values. So find the reaction to each support, 3G newtons, 4G newtons, job done. If you did multiply by 9.8, then you would make sure that you give your answer to two significant figures.